Alright guys, I'm going to post the videos that are a part of Jupiter, Saturn, and Uranus's section on the slideshow.
Born from primordial stardust 4.5 billion years ago, Jupiter was the solar system's first planet. And much like its namesake, the king of the ancient Roman gods, Jupiter was destined for greatness. Jupiter is the fifth planet from the Sun and the largest planet in the solar system. At approximately 11 Earths wide, Jupiter has twice the amount of mass as the other planets put together. But unlike Earth and the three other terrestrial worlds, Jupiter has no solid surface. It may not even have a traditionally solid core. Rather, this giant planet may have a dense liquid center surrounded by a worldwide ocean of hydrogen and helium gases. Jupiter's gaseous composition can be observed in its atmosphere. About 44 miles thick, the atmosphere is a canvas of stripes and storms churning across the giant planet. Their colors range between shades of whites, yellows, browns, and reds, all caused by the different chemical makeup of each area. Probably the most iconic feature of Jupiter is a crimson-brown storm that's been raging for over 300 years. The Great Red Spot. It's a giant swirling collection of clouds with wind speeds of up to 400 miles per hour, at least 2.5 times faster than Category 5 hurricanes. Floating hundreds of miles above the storms of Jupiter are about 79 moons, the most of the 8 known planets. The 4 largest moons were discovered by Galileo in 1610. Called the Galilean satellites, they include Io, the most volcanically active celestial body in the solar system, Ganymede, the solar system's largest moon, even larger than the planet Mercury, and Callisto and Europa, which, along with Ganymede, may contain oceans of liquid water underneath their crusts. Jupiter's large collection of moons is only made possible by the planet's massive size and gravitational pull, the strongest of all the planets in the solar system. This incredible gravity also influenced the sizes of the 7 other planets. During the solar system's earliest days, Jupiter, being the first planet to form, attracted and destroyed space debris that would have helped the other planets grow in size. Today, that force may serve as a shield by attracting comets and asteroids onto Jupiter's own surface, preventing them from crashing onto inner planets like Earth. Apart from the Sun, Jupiter has become the dominant figure in the solar system, thereby earning its place at the top of the planetary heap as king.
Okay. Sorry, my computer is not wanting to cooperate. Okay, and all of this is what we've already touched on. All right, here's another video.
Jupiter could be considered an independent solar system, only in miniature form. The gas giant has the same basic ingredients as the Sun and is surrounded by dozens of geologically diverse moons. Out of the 79 confirmed surrounding Jupiter, 4 ancient moons have astronomers really excited because they offer up some of the most distinctive geology in the solar system, including clues of deep subsurface oceans that could be home to life. The Galilean moons are named after Galileo Galilei, who first observed them in 1610. Io, Jupiter's closest Galilean moon, is unusual because its composition is closer in comparison to the terrestrial planets than the icy bodies that surround it. Io is also the most volcanically active body known in the solar system, with over 400 active volcanoes. This is due to the internal heating produced by the pulling and stretching effect of Jupiter's gravity and smaller neighboring moons on Io as it orbits Jupiter. That same tug-of-war heating effect is the reason why some astronomers believe that Jupiter's second Galilean moon is home to a deep subsurface ocean, up to twice the volume of Earth's oceans. Unlike Io, Europa has an icy surface, but below it, astronomers think there may be a salty ocean that could harbor life-bearing chemistry, including organic molecules. When Europa swings by Jupiter on an elliptical orbit, gravitational tidal forces stretch and flex the sides of the Moon, creating internal friction that essentially heats the Moon from the inside out. Using its Europa Clipper spacecraft in the 2020s, NASA plans to get a closer look at the Moon in order to confirm the existence of a potential ocean. Europa's neighbor, Ganymede, is also believed to have an ocean hidden under its thick icy shell. The Moon's magnetic field may be affected by an electrically conducting layer from within, which hints at the existence of a liquid saltwater ocean. But Ganymede's distance from Jupiter means there's a weaker tidal force at play, so it's less likely that liquid water is present. The Moon is the only one in the solar system known to have a magnetosphere, protecting its surface from harmful radiation and solar wind. As Jupiter's largest moon, Ganymede would be considered a planet if it were orbiting the Sun. Out of all 4 Galilean moons, Callisto is the farthest from Jupiter. The Moon is purported to be one of the most heavily cratered objects in the solar system, with some impact basins expanding to about 2,600 kilometers across. These craters could teach us a lot about the formation of our early solar system, as astronomers believe its surface hasn't changed in over 4 billion years. Unmanned spacecraft have been conducting flybys of the Galilean moons for decades, and findings from these missions suggest an even greater presence of water. Along with NASA's Europa Clipper, the European Space Agency's Jupiter Icy Moons Explorer, aka JUICE, will gain a deeper understanding of the moon's mysterious properties. But getting to these moons will be no small feat, since the craft will need to slingshot around the Sun and then travel about 800 million kilometers before being caught by Jupiter's massive gravitational pull. If the spacecraft can survive this arduous journey and manage to generate enough energy to travel between the moons, astronomers will gain an unparalleled glimpse into what lies beneath their surfaces, which could even result in the discovery of the first forms of life beyond Earth. Spacecrafts takes you through the depths of the cosmos, explaining bizarre astronomical phenomena and crazy plans for future exploration. In this episode, we explain how an advanced civilization could
Okay. This video, we may not watch all of it, but it explains Jupiter's rings. Okay, we'll stop right there. Alright, moving along to, well, Saturn.
With its gold color and stunning rings, Saturn is quite a planetary gem. Saturn is the second largest of the 8 planets, and it is about 10 times as wide as Earth. Despite its size, Saturn is actually the lightest planet. It is predominantly made of the gases hydrogen and helium, and because of its particular gaseous composition, Saturn is the only planet in the solar system that's less dense than water. If the planet were placed on an enormous ocean, it would be able to float. Saturn's gaseous makeup also means that it has no true surface. At its center, the planet has a dense core of water, ice, and rocky material, but it has no actual landmass. Instead, it's mostly made of gases, liquids, and yellow ammonia crystals that swirl around the planet, creating golden clouds and storms. The largest storm on Saturn is at its North Pole. It's over twice the size of Earth and shaped in a near-perfect hexagon. Each of the 6 sides is believed to be the result of jet streams, which all encircle a massive hurricane. Because of Saturn's inhospitable environment, the planet cannot support life, but some of its moons might. Saturn has more than 50 confirmed moons, and each varies in size and terrain. Enceladus, one of Saturn's smallest moons, is covered in ice and only about as wide as the state of Pennsylvania. Titan, Saturn's largest moon, is nearly as wide as Canada. Titan is also the only moon in the solar system with clouds and a dense atmosphere. Both Titan and Enceladus have underground oceans that would make them potentially capable of sustaining life. Saturn's moons may also play a role in shaping the planet's signature feature, its rings. Saturn's ring system is the largest and most complex in the entire solar system. The rings are made of icy and rocky remnants from comets, asteroids, and moons. The particles range in size from being as small as dust to as big as mountains. The ring system is divided into 7 groups of rings. Altogether, they are as wide as 4.5 Earths, but only about 2/3 of a mile thick. How the rings are able to stay on track and intact has to do with Saturn's smallest moons. Called shepherding moons, these tiny satellites orbit between the rings, and they seem to use their gravity to shape the ring material into circular paths. Saturn has fascinated scientists and amateur astronomers alike for thousands of years. The ancient Greeks and Romans, who named the planet after their god of agriculture, believed it was a star. It wasn't until the 17th century, after the telescope was invented, that scientists like Galileo Galilei, Christian Huygens, and Giovanni Cassini could take a much closer look. Only then was Saturn's planetary status discovered, and, ultimately, its many moons and brilliant rings. Because of its planet-like moons, lightweight composition, and dazzling ring system, Saturn continues to mesmerize us to this day.
Moving along, we should be able to get done in just a second. Click here. Computer is not wanting to cooperate at all. Alright, and now for Uranus. Let's find those videos.
In ancient times, humans studied the night sky and discovered the worlds of Mercury, Venus, Mars, Jupiter, and Saturn. But beyond this realm of knowledge, another world shined brightly, just waiting to be discovered. Uranus is the 7th planet from the Sun. From a distance of about 20 astronomical units, or 20 times the distance between Earth and the Sun, Uranus orbits the star once every 84 Earth years, approximately the length of a human's entire life.
Okay, be sure that you're listening and paying close attention. A lot of the facts that you're going to get can come from the videos as well, so remember you can pause and go back.
This orbit causes each season of Uranus to last that much longer. Theoretically, a human living on Uranus would experience the 4 seasons only once, but each for about 21 years. Partially due to its distance from the Sun, Uranus boasts the coldest temperatures in the solar system. These icy temperatures, dropping as low as -370 degrees Fahrenheit, are largely influenced by the planet's composition. At about 4 Earths wide, Uranus has an Earth-sized core made of iron and magnesium silicate. The remainder, approximately 80% of Uranus, is a worldwide ocean of ices made of water, ammonia, and methane, the chemical behind the planet's cool blue color. This icy composition prevents Uranus from emitting much heat compared to other planets, making the blue world the solar system's coldest. In addition to its extreme temperatures and orbit, Uranus has a dramatic orientation. While the other 7 planets spin on their axes like tops, Uranus appears to roll along its equator. The planet is tilted at a near right angle, in which polar regions point toward and away from the Sun rather than upward and downward. This tilt, thought to be the result of Uranus's collision with at least one celestial body, has also affected the orientation of Uranus's 13 rings and 27 known moons. Unlike the rings and moons of other worlds, which orbit their home planets horizontally, those of Uranus orbit in a vertical orientation along the planet's tilted equator, much like a Ferris wheel. Uranus and its many unusual features were a mystery to the ancients, and the planet was actually thought to be a star. But in the late 18th century, astronomer William Herschel discovered that the celestial object was actually a new world. The scientific community debated over what the planet should be called, and eventually chose a name suggested by astronomer Johann Elert Bode. Bode believed that since Jupiter was the father of the gods, and Saturn was the father of Jupiter, then this new planet should be the father of Saturn, Silus. But rather than following the tradition of using names from ancient Roman religion, Bode instead opted for Silus's ancient Greek equivalent, Uranos. Uranos, the ancient Greek god of the heavens, was then Latinized to be Uranus.
Okay. Alright guys, well you've already watched that video, so that's it. This will help us get caught up from the week we were out for the snow. Tomorrow we will cover Neptune and the Kepler belt. So I'll see you guys tomorrow.